This is the last video of this school year. This is the week 27 test. We've got two concepts to cover here, 25.1 and 25.2. So let's jump in. 25.1 is probability with sample spaces. Now remember, when we talk about sample spaces, right there, sample spaces, we're talking about a way of organizing information. So the first thing they ask us to do in this problem, way up in the instructions, make a list of the possible ways these three students can finish in first and second place. And the three students that we're talking about are right here: Sophia, Natalie, and Matthias. So let's jump into our sample space. Well, here are the ways that students can finish. They can either be first or second or third. So for Sophia, she could be first with Natalie second and Matthias third, or Sophia could be first with Matthias second and Natalie third. Now, it's also possible that Sophia doesn't finish in first, that instead Natalie finishes in first, and Sophia comes in second and Matthias third, or Natalie could finish first, Matthias second, and Sophia third. I bet you're seeing the pattern here. Finally, it could happen that Matthias finishes first. She's the best speller. Sophia comes in second, Natalie comes in third, or Matthias finishes in first, Natalie second. Sophia has a rough day at the spelling bee, comes in third place. So we can see that altogether there are 6 possible outcomes. When we talk about outcomes, we are talking about possible things that can happen. There are 6 things that can happen. The second question is, how many outcomes place Sophia in first place? And we can see there's an outcome right there. Sophia's in first, Natalie second, Matthias third. And an outcome right there. Sophia first, Matthias second, Natalie third. So, 2 outcomes that place Sophia in first. All right, our second question on this test, shortest test of the year. Well, maybe not. It's just like the first test of the year, which also only had a couple questions. Emma spins a spinner. Now you notice the spinner has 5 sections. They're all equal in size, which means they're equal in probability. And the question is, what's the probability that both will land on 4, that this 4 comes up twice? So remember, our probability, our way of figuring that is to say, because here's what they're asking us. If I go all the way over here, they're asking us, what's the probability of getting 4 and 4? So to solve that, we look at the probability of getting 4 just one time. Well, there's 1 4. There are 5 possible. So since there's only 1 4 out of 5 possible, the probability of getting a 4 is 1 out of 5. And the probability of getting a 4 the second time is 1 out of 5. To calculate this combined event, or what they actually call a compound event, to get the probability of this compound event, what we do is we multiply the probabilities of the individual events. So right here we said the probability of that 4 is 1 out of 5. And the probability of that 4 is 1 out of 5. And to get the total, then we multiply those together, and we get 1 out of 25. There is a 1 out of 25 chance that you can get 4 twice. If you built a table and you showed all the possible outcomes, there'd only be 1 out of 25 possible. Now let's look at that a slightly different way. Let me scroll here and get a little more room. In fact, I'm going to need to go all the way to there. Let's look at this a slightly different way. Here are the things that can happen. You can get a 1, a 2, a 3, a 4, or a 5. So that means 1, 2, 3, 4, 5. These are my 2 possible sets. This is my first spin. And this is my second spin. So now let me go ahead and grab something here. I'm going to grab a tool to make it a little easier to draw some lines. And I'm going to put some lines right across here. Oops, stop that line too soon. There we go. And a line right there. Right there. And we'll squeeze in one more. And it looks like I could actually take maybe, we'll see, let me grab this whole thing and move it up just a little bit. I'll actually spread it out. There you go, and move it up. Nice. Okay, now let's get the other lines here. So we're going to also have lines going this way. What I'm building is a sample space. In this case, the sample space is a table. Sample spaces can be tables, they can be lists like we had at the top. All these things are called sample spaces. And you can see that there is only one place in this sample space, one spot right there, where you get a 4 and a 4. And you can count, looks like I stopped one line short of what I should have had here. Let me put in my last line. Just have a line right there. And you can count, and you can see that if you count 1, 2, 3, 4, 5, 10, 15, 20, 25, there are 25 different spots altogether. Only one of them is a 4 and a 4. All right, now let's set up to solve question number 2. Question number 2 says, what's the probability that both spins are greater than 3? So again, compound event, they're asking us the probability of getting greater than 3 and greater than 3. So what's the probability of getting greater than 3 one time? Well, 5 again, spots, equally sized spots on the spinner. 2 of those are greater than 3, the 4 and the 5. So there's a 2 in 5 chance that you'll spin greater than 3, which means the second time you do it, when you spin it the next time, you're going to have a 2 in 5 chance. And once again, we would take the 2 in 5 times the 2 in 5, which is a 4 in 25 total, and that would be my answer right here. There is a 4 in 25 chance that you're going to spin both greater than 3. And if we go down to my sample space that I built, that spot in the table is right here. Greater than 3, greater than 3. None of these are all equal to 3, so we can't use any of those, or the 2s or the 1s. We can't use these, the 2s or the 1s. But we can see here's a 4 and a 4, here's a 4 and a 5, here's a 5 and a 4, here's a 5 and a 5. Those are the only ones where both spins are greater than 3. All right, lastly, I'm going to use my sample space table to solve the final part, part C. What's the probability that the sum of the 2 spins is less than 7? I didn't draw that line very well, did I? Sum of the 2 spins less than 7. So let's look at the sums. Here we have a 1 and a 1. If we sum those up, we get 2. Here we have a 4 and a 1. If we sum those up, we get 5. A 5 and a 1, we get 6. That's less than 7. A 4 and a 2 is a 6, less than 7. A 3 and a 3 is a 6, less than 7. A A 2 and a 4 is a 6, also less than 7. A 1 and a 5 is a 6. A 3 and a 2 is a 5. And you can see a pattern here. This is going to be 3 and 1 is 4, 2 and 2 is 4, 1 and 3 is 4. 1 and 2 is 3, 2 and 1 is 3. And these are all the ones less than 7. If I get to this spot, 5 and 2, I get 7. 4 and 3, I get 7. 3 and 4. None of those work. So it's all these ones in red, and there are 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of them. So the probability of a sum less than 7 is 15 of 25, which simplifies to a 3 out of 5 chance. All right, that is the week 2 test. Here are all the answers. Let me scroll so you can see everything. There you go. This was the answer to our last one right here. And I said if you didn't simplify, that was okay, but you should write the simplified down just so you remember to do it in the future. So there you are. Last test of the year. Remember, there's still an opportunity during this final week and a half of school to do some intervention tests, so don't give up on yourself yet.